Hello, my name is Heli Hendesi, and I'm Senior Content Manager at ASCM. It is my pleasure to be your host for today's webinar, Product Development in a Digital World. Today, I'm joined by Jesse Singh, Jason Edmonds, and Emily McAdams from Deloitte. Jesse Singh is Senior Manager, and he has over 20 years of consulting and industry experience founded in product development and commercialization, product management, R&D, business transformation, supply chain, and manufacturing operations across all stages of product life cycle in the different sectors, including technology, life sciences, and consumer and industrial. He holds an MBA from Marshall School of Business at USC, Master's in Regulatory Sciences, and a Master in Biomedical Engineering from University of Southern California. Jason Edmonds is Senior Consultant at Deloitte, and he has over 10 years of diverse project and program management. He has delivered a strategic and digital transformation consulting to clients across industries. He has worked on a variety of supply chain projects, including multiple MBD and end-to-end digital thread projects. He holds an MBA with a focus in supply chain management. And Emily McAdams is Senior Consultant within the supply chain practice with experience in technology, healthcare, aerospace industries. At Deloitte, she has delivered multiple supply chain strategy projects for aerospace and defense clients. Emily holds an MBA from UNC Cannon-Flagler and bachelor's degree in electrical and computer engineering from Cornell University. It is now my pleasure to present Emily, Jesse, and Jason.
Thanks, Heli, for the warm welcome, and looking forward to a exciting session to introduce product development in the digital world with the digital capabilities model. So today, as we go through a few sessions, we've broken this down into 6 topics. We're going to be working through the digital capability model, a quick refresher on the journey, so that everybody has a background on where we are coming from. Then product development in the digital world. What is changing? What is new? What is different? How do we go about it? And why now? Then the digital capability model, also lovingly known as the DCM, the elements of the capabilities in this pillar. Then we'll be looking at the DCM product development capabilities and the other pillars in a demo of the website on how things come together on that front. It's an interactive tool that we are very excited to share with you. And then how do we make this real? So we'll be looking at a couple of case studies in terms of how the DCM model has been deployed in the actual space and the lessons we have learned, the impact that we've been able to create. And we'll be closing it up with some of the Q&A sessions from here on. So let's get a quick refresher on the digital capabilities model journey, what we have done, what we are trying to do, where we come from. So the classic supply chain that the SCORE model has been very successful in defining and helping the industry shape up is laid out right here. And it is a linear process that takes us from a plan to source, to make, to deliver, return, and it has few enabling capabilities and capacities underneath it. But what is changing? The customer preference for a highly personalized and smart connected products have amplified the dreaded bullwhip effect to a new level. Things are changing too fast, reaction times are short, and how do we come together? So the 2 key elements that need to be called out here are the product development and customer service, which used to be in the enable layer in the DCore and PL core models, have now been elevated up to the same level in a very integrated model that you see on the right-hand side, which is the digital supply network. The interaction with customers is no longer a one-time event at the sale, but a continuation of a relationship that goes on from opportunity to deliver to monetize additional value as new experiences, offerings are added post that initial sale element. This requires an upgradable offering that can be delivered in a timely fashion. typically delivered with the software-led features. And a great example of this that everybody can relate to, a smartphone. The first time you buy the hardware, that's the one-time sale that happens, the first-time sale that happens. And then how do we continue to enhance with the new apps, the new features that are ongoing transactions post the initial sale for an extended period, which allows for additional monetization. Having the ability to lead this in a structure now allows an opportunity to deploy product development as a competitive advantage. As we looked at the SCORE and DCM models, let's do a quick scan of how they are same, how they are different. So there are 5 main elements with which we will see this open up. First being the paradigm between the two. As you look at the structure between these two models, the SCORE on the left and the DCM on the right, it is going from a chain, a supply chain, to a digital supply network. The structure, a hierarchical decomposition on the left, making way for a relational digital cord on the right. Our model orientation. In SCORE, we had a very well-defined, disciplined way of process definition. Process being the key part that served us across plan, source, make, deliver, return, and some of the enabling elements. On the right-hand side on the DCM model, what we see are capabilities. It now matures to becoming a capability, which is a combination of process, people, technology, and how do we fit, how the capabilities continue to mature, how the leading practices continue to be the new targets to go after, and how do we develop them and operationalize them. An end-to-end orientation from a SCORE perspective, it's a linear transaction structure with some engagement with the adjacent parties, to a concurrent collaboration on the DCM model side across the key pillars, the 6 that we call out here in connected customer, intelligent supply, synchronized planning, product development, smart operations, and dynamic fulfillment, and how they continue to interact at this level as well as the levels below. And last but not the least, the relationship with technology, the key backbone on some of these elements on how the data moves. So on the SCORE side, the tech implemented the leading practices. In the DCM model, tech transforms those leading practices to a new level of capability customized to your local needs of your organization that gives you that strategic advantage to do some things which are true differentiators and are monetizable. So to sum it up, it is an interconnected network that operates by sensing the inputs. Inputs coming from demand profiles, customer feedbacks and needs, trends, field performance, supply capacities, etc. As these inputs are taken in, now how do we collaborate across the various internal and external partners across all the elements that are required to address those inputs that we need to do, and then addressing the situation. The situation at hand, it may be coming from changing market demand to a changing customer preference, to how do we deliver to a new feature that is needed, and how do we build and pull this thing together to respond to that input signal that we receive. So sense, collaborate, optimize, and respond in a collaborative fashion on an ongoing basis with an interconnected model. This journey that started back in 2018 has been a very exciting situation and a place to be, where the project kicked off in 2018. The first release was done in 2019 to a very well reception across the community from ASCM as well as the SCORE users. We defined the high-level pieces, the first vision, the capability, the journey maps, the personas. How does the change impact our roles, profiles, operating structures? How do we come and deliver it? In 2020, we built upon that by taking the inputs that we got from the advisory council, from the academic council, from ACM, user community, as well as Deloitte's experience in the marketplace. and we developed and released a L2 capability mapping in metrics library. How do you map the DCM capabilities to score elements as we transition from score to the DCM model? And in 21, we are looking forward to actually bringing a few more exciting things, which are built upon the digital enablement layer, the pieces that brings all of these things together. How do we operationalize? What's the core that needs to be in place to build upon all these edge capabilities and all these applied capabilities on top of it? Implementation. It is great to have a model, great to have a view, but how do I make it work? What are the steps? What is the methodology with which I go? Will be another piece that we will be bringing to the audience and the ASCM membership. And then, based on all the good input, feedback that we have received, there is going to be continued enhancement of the content that we receive, and we will be sharing that in the next release. So looking forward to that in 2021, October. Stay tuned. So with that journey in place, things are in a good spot for us to transition to the next topic, which is the product development in the digital world. Product development is not a new concept, but it has come a long way from the time where things were started. You make it, you put it out, people will come get it, to a new way where you have to build what people need to satisfy that demand. And how are the pieces connected? But still, there are some things that are changing. So what is new? A collective impact of technologies is creating a potential for an exponential change. It is not one enablement. It is a collection of all these things, the nanotechnology, the robotics, the quantum computing, the artificial intelligence, the connectivity, the 5G networks, the augmented reality, the 3D printing, the additive manufacturing. How do we bring all these things together? One by one, they have their impact. But when you put all of them together or some of them together based on your needs of the business, you can actually create a really strong impact at an exponential scale. Now let's take a look at a short video to bring this to life and see how things come together and what does it mean to be innovating at an exponential scale.
Developing successful new products and services is key for high-tech companies' future growth. New and emerging technologies offer exciting market opportunities. Capturing these opportunities will require an extremely efficient product development engine, leveraging the latest digital capabilities. Doing so will unlock tremendous value and allow you to realize your organization's full potential. That's why we're here. At Deloitte, we have over 25 years of experience partnering with our clients to achieve their vision and drive value across the integrated enterprise. We bring depth and experience in delivery to help our clients transform and evolve their products. We transform business models from product and component optimization to designing new operating models to helping you move to engineer to order, configure to order, and flexible consumption business models. We transform processes and IT, like product development and new product introduction processes, enabling a digital twin thread through PLM, MES, and ERP transformation, and post-merger system integration. And we transform your products through software modernization, building product telemetry, analytics, and monetization strategies and tools, and working to develop and test your product features. Deloitte recently partnered with a leading data center equipment and services company to transform their global product and engineering functions. We standardized their product development processes and operating model across the globe, enabled the digital thread by bringing their engineering systems onto a single cloud platform, and optimized their components into a single library. Deloitte also partnered with another leading high-tech company to help them modernize their product offerings and move to a monetization strategy including subscription-based models. We worked with them to enable a new worldwide e-commerce channel and moved their entire development community to a newly developed cloud-based platform. Deloitte is focused on working with clients to achieve meaningful value across the organization. Measure us not just by what we do, but by the value we deliver. Imagine what partnering with Deloitte can do for you.
So as you saw in the video, this lays out a very strong vision, a vision for a digitally enabled world in which we are building products which are digital in nature. We are building them digitally, and we have a collective DNA of an organization which can actually deliver to the new needs with the new set of tools enabled by the new set of technologies. A lot of words on the slide. I won't drain it out. Let you take a look at it. But what truly is new here? So let's understand what is driving this situation. So the collective impact of maturing next-gen technologies, the connectivity, the AR, the simulation, the robotics, the AI, digital storage. This is enabling a physical digital loop. And that loop is where we have the potential for an exponential change in the way we conceive products, design products, build products, and deliver products, and the products are consumed by our end customers. And mastering this physical digital loop, when do you stay, how long do you stay within the digital realm, and when do you translate it to a physical piece, is key to a product digital enterprise across three fundamental domains. As I said, developing digital products and services, which is the first part of it. What do I need that I can make software-led versus hardware-led? How can I get to responding to my customer needs in a timely fashion? Developing digitally with a simulation-first approach. How do I reduce my time? How do I reduce my prototyping cost? How do I reduce my testing costs and times that are associated with it? What are the learnings that I can bring from my prior experiences, from the field, from all the inputs that I can get so that I can simulate and optimize to a large extent before I move into the physical domain, the piece that I call the physical digital loop. How quickly can I come over to the other one? And then last but not the least, the digital DNA, an agile organization of highly skilled and outcome-focused teams, which are supported by the technologies from robotics to simulation to AR to AI that helps you actually do the job better, spending less time on things that are low value add and focusing on places where that high-powered, highly skilled team comes together to deliver it in the right fashion. And this exponential innovation capability now can transform product development as a business strategic competitive advantage, not just a functional group that delivers certain things, but actually a competitive advantage to the business. So what does it mean for product development to go digital? A lot of words on this slide, but let's start with what are the key challenges we are trying to solve. Industries facing some common challenges across the board, no matter if it's manufacturing, if it is life sciences, if it is high tech, if it is healthcare, if it is service oriented, any of the operations. Products, hard products, soft products, anything that adds value is a product, needs to be looked at the same way. So rapidly shifting customer behavior, declining engineering budgets, increased complexity in engineering, unstable inputs and shifting timeframes, reduced time to market expectations. Everybody wants it yesterday. Need for virtual collaboration. COVID-19 has made sure that even when we were slow to adapting it, we are on an accelerated path in virtual collaboration. Our ecosystems have become complex. Everybody cannot just do it everything in-house. Even the largest organizations in the world are now in an ecosystem with many other partners that bring together, which is a very different dynamic from a vendor and a supplier relationship to a company. And we have so much to do. No matter how many people we hire, we are always have a limited engineering capacity. So what is shifting here? So the four fundamental pieces, if you look at the bottom left of the slide, what is changing? Products and assets, process and data, technology, and people. The four domains against which things are changing. From disconnected products, specifications, physical assets, we're now going to a synchronized digital and physical assets for both services as well as tangible hard products. Digital twins is a classic example of how we are bridging that gap. From a formal product launch and fixed development timelines, which were tied to a scope is fixed, the timeline is negotiable situation, to agile innovation, which is more tied to being very responsive to the customer experience, to the data coming in, and how quickly can we continue to improve upon the product. So it's not a one-time make and sell, it is an ongoing product development, product improvement, product enhancement as we expand the customer experience and elongate the product engagement lifecycle with our customers. Going from design data records to electronic systems. A lot of drawings being done, printed, handed out. Manufacturing taking those designs, translating them into machine code, CNC machines, and then starting to work on them. Why do we need to have a model, a digital model to a physical paper, then again getting transferred? So how can we now connect all these pieces together? The process twins, the product twins, everybody working from the same base data model. We'll be highlighting this in a model-based definition use case, which will bring this further to life. To now leveraging advanced technologies and analytics, providing the pieces into it, not just static data, but dynamic, smart data, which is being mined for information. And last but not the least, traditional roles, responsibilities, and methods. A very key important part as we make this transition. How do we upskill the teams, the people, the talent that we have as we enable the new capabilities with the digital DNA part of the world? The three coming together, building a digital product, building it digitally, and the digital DNA that enables you to actually do the best with what you have. And the business impact is significant. If I may draw your attention to the right-hand side of the slide, the impact that we are seeing in the marketplace, the companies, the organizations that are going towards this, they are transforming to this, increasing speed to time to market by 50% in many cases, reducing engineering cost from 20 to 50%, a significant chunk of this becoming from how much can I simulate before I start cutting metal and start spending money in hard prototypes. And then the number of hard prototypes needed is also being reduced. There is a direct tangible impact to the market share increase by offering products in a timely fashion, meeting the needs of the customers, which is giving you a top line lift. All parties coming together, all pieces are interacting, people are working from elements of a common digital model, helping reduce cost of quality. The late stage design churns which were needed, oops, somebody made a mistake because somebody was not paying attention or did not talk to the right person downstream, can now be handled fairly quickly in a timely fashion before some hard decisions are made and not have to try to find band-aid fixes to those. And product development efficiency by itself. A lot of engineering time is spent just chasing old data, not having access to the work that has already been done. So you are redoing certain things. You are recreating tests. You are rerunning things which could have been easily taken in if the connectivity existed across the board. And last but not the least, everyone having that insight, the ability to see, communicate, have a transparency into where things are, again, reducing a lot of effort and a lot of concern to where everybody is, where things are, where do I stand. It is a clear-cut view and everybody operates from the current information and not a stale data set. So with that, let's transition into the next topic. All this is good. how do I actually put it to work? I will look forward to my digital thread. I will look up to my great things that we can do, the digital product development elements. How does this actually start to translate and get tangible? This time, the product development capability has few new names on it. Those who may have seen this from release 1 may find some of these names changed. And one of the key pieces that has changed in this view, where you have the 5 level 2 capabilities, the product and portfolio management. This is a net new capability that we have introduced in this model. This is what to build, putting the connections and interconnects between technology roadmaps to product roadmaps to what products are in the marketplace, how they are behaving, how they're performing, and how do we need to make adjustments to it. Product development collaboration, how the various groups, internal and external, come together to actually build the product. A product which is a tangible product, a service, a combination of the two, a pure experience, anything of value that the customer would care for. As things come together, how do we actually define the product? What is our product platform architecture? What's our system engineering approach in pulling those pieces together? Because very few products are left at a very simple level. The engineering complexity is going up and up and up. How do we manage that complexity? How do we break it down into chunks? How things come together? Digital development. How do we develop things digitally? As I mentioned a few minutes ago, mastering that physical digital loop, how much I can do in the digital simulation space, the more the better. And then as things are coming together, we need to know what we are building, who's building, what is in it. The personalization levels are going up and no signs of coming back. So the configuration of the product from the design to what is sold is equally important. So configuration management across the life cycle of the product becomes a very key critical capability that we need to look at. A quick recap for folks who would like to get some accounting in terms of what we did in 2019 and 2020, what came out in the release R1 and R2. So first column, original title is from the original release, R1, revised titles are from R2 that we are coming with. So the key rationale on this was, why did we have to update? Why did we have to consolidate? This is coming from all the good input that we received from our advisory council, both academic and industrial, as well as experience in the marketplace that we have developed over the last couple of years, where it resonates the best how the organizations think and structure these capabilities across functional domains, and maturity improvement are the key drivers with which we went ahead and revised these titles for. And from here on, I'm going to hand this over to Emily to walk us through the details of what is happening in these new revised L2 capabilities, the library of metrics that we have laid out for you, as well as the capability maturity models that help us provide the reference framework and a reference model against which we can help then start to establish what good looks like and what the journey would be from there on.
Great, thank you, Jesse. So as mentioned, we'll get started first talking about some further definitions on our level 2 capabilities that we've defined for product development. So you can read through the definitions here on the slide, but we'll just kind of walk through each one briefly and then move into some more details on the content. So starting at product and portfolio management, this is a capability that enables the establishment of operating models and frameworks that are key for that end-to-end product lifecycle management. This would include your future product plans, your roadmaps, as well as planning and managing end of life for product. Going down the list, product platform architecture and systems engineering. This is defining and managing both your hardware and software requirements, which is becoming more and more important as products are moving to hybrids between hardware, software. This includes defining the platforms that are needed and all of your requirements in order to design for X. That would be designing for quality, for manufacturing, for your customer. So really, managing all of those, architecture requirements and systems requirements. Going down into configuration management. This is defining your ability to manage your product data across the product lifecycle. Maintaining good product data integrity is key to ensuring your quality and efficient operations. Product development collaboration, enabling your organization to work across your quote unquote conventional boundaries and integrating product strategy and development with both internal and external stakeholders. And then finally, the digital development capability, which is bringing together your digital convergence, managing and developing your products digitally, and including synchronized digital and physical platforms, allowing for real-time collaboration across stakeholders. So diving the next layer down, this takes us to our L3 definitions. So as we get started, I will note that these are not currently part of the release content, but will be part of a follow-on release. The L3s really help flesh out and define what it takes to implement the different L2s. I won't go into the specifics on each individual L3 on the slide, but we'll talk through a few highlights and talk about how they connect across the product development capability. So starting from the left with the product and portfolio management L2. So within that L2, the portfolio management capability is really that key connective tissue that you need to manage your product across the end-to-end lifecycle. Within your platform architecture, there are market drivers that are driving companies to need to improve their product release cycle length, as well as reducing costs. So design, reuse, and standardization is a key capability that drives your requirements management, as well as design, simulation, and test, and bringing all your L3s come together to enable that design for X we mentioned earlier. Continue to move right. As was mentioned earlier by Jesse, customization is another critical requirement in today's environment. So configuration management includes the L3 capability for variant and option management. This further defines how do we efficiently manage those custom requirements that are coming from the customer. Next, looking within product development collaboration, a key highlight there would be the design thinking L3. This enables the ability to solve your customer problems with an end-to-end lens. And then, of course, within digital development, we're going to talk a little bit more in our use case section about model definition and how using model-based definition enables real-time collaboration between both your internal and external stakeholders and breaks down those traditional barriers that you have previously seen. So, just a few examples of how this forms the connective cord across the product development L1. We'll dive into more of that in the use cases. But first, we want to keep talking about some of the additional content that has been part of this release. So the next key component here is a refreshed set of KPIs. These metrics are building on ones that were previously defined as part of PL Core and SCORE. But we've added additional metrics that align to the new and revised capabilities within the product development L1. KPIs can be used to both measure your improvements that are driven by implementation of your DCM capabilities, as well as monitoring the performance of these capabilities over time. Some highlights and examples, you'll see a lot of metrics pertaining to cost improvement, cycle time improvement and monitoring, quality improvement. And as we'll see when we walk through the website, that each of these metrics includes a detailed definition and calculation for how to use this KPI. So finally, moving on to the capability maturity model. So as you may recall from earlier, one of the key tenets of transitioning from the SCORE to the digital capabilities model is the need to have maturity across many capabilities that complement each other. Capability maturity models provide a reference to understand what is needed and where does an organization stand and how can they identify gaps that need to be filled. They can also be used to monitor on an ongoing basis as you continue to mature the capability. One other thing to consider when looking at the capability maturity models is that companies may have a diverse matrix of capabilities. So an individual organization should identify, what are the important maturity levels for that particular organization. What we've defined as part of this effort is the L2 capability maturity model. Deloitte has further libraries of capability maturity models that dive deeper into the L3, L4 details, so that if interested, you could get an even further resolution into where your organization stands as far as overall maturity. So as you go through the content with this webinar, you can read through the capability maturity models here, and then you can also access and look through them on the website. So at this point, we'll transition over to a demonstration of the current content on the DCM website for product development. All right, so what you guys can see here, this is the landing page for the DCM model. Each L1 has a different node in the model that you can click and then see the different L2s. On the right-hand side, you can read through the definition and then further see, how you would navigate to dive deeper into each L2 content. Worth noting from this view, if you click on individual L2s, you can actually see how those L2s link into the other L2 capabilities across the DCM. So this gives you the ability to navigate through the web of connections and really build out that cord for your different use cases. So this is something that's new with this current delivery, and you can see the frequency of the relationship between the different L2s, whether there's a high, medium, or low relationship as you look through on this view. So going back to product development, we'll click into one of our L2s as an example. If you follow through on the Learn More, you can see a lot of this content that is new as part of this release. So again, the definitions that we talked through previously, you can read through them here. A quick overview of kind of what's new and why these L2s are so important and how they connect into the overall product development capability. As mentioned, the capability maturity models are incorporated within this view as well. So you can read through and assess where you feel your organization may fall for these individual L2s. It also includes information about how the individual L2 capabilities connect to the different L1s within the DCM. So again, this is another way to navigate the web and see the details of how each capability within the model connects across. Next, you can see the different impact on the digital disciplines. So sense, collaborate, optimize, respond. How does this particular capability enable organizations to function in the digital world specifically? And then finally, as we mentioned earlier, we talked a little bit about the KPIs and the ones that have been delivered for product development. So within each L2, you will see the metrics that were associated with those particular level 2 capabilities. You can scroll through and see those here. There may be metrics that are associated with multiple level 2 capabilities. So just as you're navigating through, you may see some metrics that are similar across the different level 2s. And then just from a navigational perspective, you could use the top bar to navigate to a different L2 within the product development space or to any other L2s within the model. So, as we kind of wrap up this section, a key highlight here is that, this model lets you navigate and interact with, the information in a way that's different and improved upon, kind of previous experiences of reading a book or looking through a long paper. So being able to quickly find and navigate the information you want and see how it can connect to other points in the model.
Thank you, Emily, for that overview of product development and the L2 and L3 capabilities, the metrics, the KPIs, all the other things we've developed over the past couple of releases. So as Emily and Jesse have described over the last half an hour or so, there's a lot of capabilities here. There's a lot of ways that you can tackle the problems that are facing industry today. So what we want to do now is pivot into basically a few case studies. One is a basically end-to-end product development digitization at a medtech company. So this is kind of the let's go wide, let's really impact a bunch of different capabilities. Let's really try to pull kind of that digital thread across the entire org and really gain the benefits across all those different pieces. And the second one here is going to be more of a focused kind of surgical strike of we're going to deploy one thing that'll have a huge impact because of some of the pain points that an organization is facing. And that's going to be deploying model-based definition at an industrial manufacturer. So let's take a pause here for a short video. This video is going to tie together basically the pieces that of the digital thread and kind of how all this comes together. And then when we come back from the video, we'll jump into kind of a quick overview of the digital thread and then the 2 use cases.
Product development is at the heart of many organizations today, and its importance continues to grow. It is the engine driving new products and services to the market every year. However, increased competition, complex regulatory requirements, and expanding product consumerization means that the pressure for organizations to innovate while continuing to increase product development efficiency and effectiveness has never been greater. This is why top product development organizations across many industries are relying on digital technologies to deliver differentiated products and services to millions of customers, while also accelerating and better managing the development lifecycle. Digitalization can transform the entire product and service development process. It delivers benefits to organizations, their employees, and their customers. And digitalization significantly reduces non-value-added activities by automating redundant tasks and creating a connected digital thread across functions, product lines, and regions. Digital technologies help reduce quality and regulatory risks by minimizing human error and using the power of data to predict where potential issues may arise. It also improves operations by reducing unnecessary downstream iterations and providing accurate, integrated data to make timely decisions. While the benefits of enabling a digital enterprise are significant, the journey to achieve it is no easy task, especially for organizations that have not kept up with processes and technology evolution. Digital transformations inherently change the way people work by leveraging the latest advancements in business processes, integrated data, and technology. This mandates new ways of collaborating and develops new skill sets. People harness the full power of digital technology every day. The future is now. Many companies have already started transforming how they develop new products and services. Are you ready to take the next step?
Great. So as you saw in the video, there's a lot of different pieces. They come together to basically form, as Jesse described, that kind of complex network. So going from a linear kind of process-driven example to more of a integrated, connected digital capabilities model that impacts cross functions, impacts internal and external, and provides that visibility across all the key elements of the organization. As you can see here, we have kind of the standard or traditional product development lifecycle across the top. So you have your launch program all the way down through maintain and optimize. You have the different roles here that are impacted, and you have this concept of digital DNA that runs throughout the organization. It spans your customers, it spans your suppliers, your regulators, manufacturing. Everybody's now connected to the same digital DNA and is able to basically extract or visualize or consume whatever piece of that DNA is most critical for them to be efficient, to improve their functionality, and to drive change across the org. You can see now that at the bottom we have a foundation of connected systems. So we're no longer working in silos of ALM, PLM, ERP, CAD, and so on. We're now connecting these together. And changes and impacts in one system are now driving changes and impacts and alerts in other systems. And this all sits on top of a nice advanced analytics framework so that you're able to use your BI tools to make data-driven decisions. People understand why they're making decisions. They understand what impacts those decisions will have. And they have the latest data at their fingertips so that they're not guessing or they're not reacting, they're proactive. So what I want to dig into now is the first case study, right? So digitizing product development at a medtech company. So this was a large company, well-known company, has branches and operations across the world, many global kind of siloed development cycles. And they were experiencing some constraints around how do these organizations, how do these different groups across different continents, different time zones, different systems even, how do they work together to start really efficiently driving and streamlining the process of product development? So as they were introducing new products, they were seeing, either competing products, repetitive work being done, a lot of pieces across the different orgs that were just leading to a lot of churn and a lot of kind of rework, right? They had extended time to post-launch stabilization. So basically here, this is the concept of we have to hit a deadline, we push something out, and we're continuing to do product development, Q&A, testing, a lot of those things into manufacturing and even into the field, right? Which doesn't help with your client base and it doesn't help with people coming to your product and consuming it. There was a lot of non-value add activity. So think of design churn. So think of somebody designs something and they take it to manufacturing. They're not able to produce it. There's not capacity. Maybe the part is unmanufacturable as designed. So there's a lot of this happening now, right? As engineering organizations try to move faster, they also need to be able to provide visibility to those people and throughout the organization that can give them feedback on what might or might not work. There's also conflicting governance, decision rights, and operating structures. So across the different siloed organizations, there were different roles, different people approving things. There's different governance and decision rights. So in some cases, things might be released to manufacturing without the proper change control or review cycles. In other organizations, it was a little more mature, a little more structured, so they had some of that change control in place, but it actually might have inhibited some of the collaboration between the two groups. And then there was gaps and inconsistencies in product data, right? So if you have manufacturing and working from like revision 6 of a product and engineering is on revision 8, now you've created a gap. Now you're having to go branch that gap and figure out when did we change to 8? Who's on 6? Who's on 8? How do we get this to the field? How do we make sure that we have support? So there's a lot of things happening there, again, that kind of inhibits or can handicap your ability to make data-driven decisions. So how do we fix this, right? So we have all these issues. These are common issues across a lot of organizations. How do we fix these? So we come into our scope and approach. So Deloitte came in and we basically helped them establish a preferred part database. So what this is essentially you take all your parts, it could be millions of parts in theory, all your records, and you do using some sort of proprietary tools and some AI, you essentially look for duplicates. You look for parts that are essentially the same, parts that are maybe like built slightly different, but have the same form, fit, and function, and you're able to consolidate that down and start reusing those parts across orgs, so that you don't have the exact same part being produced in North America and in EMEA and in APAC. You can now use one part for all 3 regions, and you actually free up some of the engineering time. We help decrease overhead and COGS, so cost of goods sold, through part and supplier collaborations. So as they as we went to the supply chain, as we consolidated parts, we consolidated suppliers. Now we started getting the best price for these parts, rather than sourcing parts for different costs from different suppliers. As I mentioned before, there was a lot of disconnect, right? So there were these silo development cycles or silo development areas, and then on top of that, you had silos and kind of those traditional walls or those traditional like obstacles between engineering, manufacturing, quality, and then post-production support. So we came in and we helped enable their digital thread so that manufacturing, quality, their customers, field services, everybody, instead of being linear, and now became a circle. So they had this circular kind of digital capability model. We enhanced their project and portfolio management. So they were able to basically target and kind of end of life projects that may not have been as profitable as they thought, ones that may have been high cost, low margin, or ones that may have even been kind of just the market wasn't demanding what they thought, so they were able to kind of fail fast, kill those projects, and move on to the ones and focus on the ones that were their highest earners. And then we integrated compliance management across the enterprise, right? So again, this being a medtech company, regulatory and compliance, huge overhead costs, huge potential time sinks for engineering, for manufacturing, for a lot of these folks to get products to market. So being able to integrate this and standardize it really helped to drive and streamline that efficiency, so that all of the organizations were doing it the same way. They now had templates in place, they had tools in place, so that they were able to basically, when they brought a product to market, they brought it to market the same way. So what value did this deliver, right? So we talked about the issues they had. We talked about how we focused and went in and looked for kind of quick win opportunities, but then also longer term ways to mature their capabilities. And we looked at the value that came out of it, right? So a 7% increase in R&D capacity. Depending on the size of your organization and how many people that is, that could be a huge increase. That could be a whole other product that maybe you release per year because you freed up that capacity. 26% reduction in time to market. So now you're beating your competitors, you're gaining market share or maintaining market share. So you're actually able to get products out there faster and get them out there first. I'll skip down here a couple. So 9.8 million and 4.7 million, basically from direct overhead material reduction. So again, going back to that part rationalization and being able to source parts, source materials, rationalize those parts and collaborate with suppliers. You've now reduced a lot of that kind of supply chain cost. And then 4.7 million per year savings and process efficiency. So now you've reduced that churn, you've reduced a lot of that non-value add activity, and you're actually seeing the benefit of those two pieces together. As Jesse mentioned earlier, because we are going digital, we no longer need to go down to the machine shop and cut metal to make a prototype. So now we're able to do a lot of that system-based engineering, and we can kind of see what might work, what might not work very early in the design cycles, and then we can go and do maybe 1 or 2 prototypes just to validate our design and prove it out. And then at the bottom here is a call out, and this was a number that we saw kind of going up over time. So this was the initial measurement, and then increasing as we move forward. But 1 million and lower cost of quality, right? So as we looked at increasing the change control process, as I mentioned before, making sure that things aren't wet out the door or released to manufacturing or production that aren't overviewed and checked over. You end up with, again, reducing a lot of that quality downstream that can have a huge cost when you want to essentially, you have to correct it. Okay, so again, moving into case study 2, the previous case study, we just saw that we were going end to end. We impacted a lot of areas from product development, supply chain, quality, manufacturing, and we had heavy impacts, right? We did a globalization, a global digitalization of their enterprise. As we move into case study 2, it's kind of one single piece of that. So it's deploying model-based definition for an industrial manufacturer. And what we're looking at here is some of the similar issues, right? So we have, kind of linear product development processes that are inhibiting or that aren't able to support their needs. Again, we have duplicate parts and assemblies. So a lot of work happening, same work happening across engineering organizations because they don't have the ability to see that digital thread and see those digital twins. There's the traditional disconnects between product development and other functions. So manufacturing, suppliers, quality, customers, they're not seeing the final products until those products have gone through that traditional cycle, which creates a lot of investment before you have any feedback. Lack of visibility into updates, changes, MPI, which creates churn, delays, and rework. So again, if your manufacturing finds out the last minute there's been a change, they may even produce product using the old work instructions or the old standards or whatever it might be. Now they have to scrap all that and potentially rework it to bring it up to the new standards. There are a lot of high supply chain costs with this client because of these last minute demands, right? So they'd go to a supplier and they'd say, I need 100 of these by next week. And the supplier would say, I don't have the capability, I don't have the capacity, or you need to fast track that demand, which as you are constantly fast tracking product, production and bringing that in-house, that creates a lot of cost. And then manufacturing, quality, services, and customers, we're still working from traditional 2D drawings. So a lot of projects, as Jesse said, they're digital, they're hardware, they're software, they have sensors built in them. They have a lot of, they're much more complex, right, than they used to be. And it's getting more and more difficult to be able to interpret drawings in a way, to see the design intent, to be able to do services in the field, to be able to, as a customer, provide feedback on maybe a customized design. So really going to model-based definition gives everyone in the organization, internal and external, the ability to see the 3D rendering of that design or of that product, of that vision, and to provide feedback on a 3D model they can actually kind of get their hands on. So again, looking at the business issues, the scope and approach. So we wanted to enable essentially real-time changes as the product development team made them. So we looked at, let's develop the digital twin, let's make renderings of that digital twin or derivatives of that twin available throughout the organization. So manufacturing, quality, suppliers, basically anybody in the organization that might be impacted by a change that's made or by MPI activity was able to come in and see the latest digital version of that product. This created a lot of cross-functional collaboration. So rather than having kind of your traditional product stage gates, every 2 months or whatever the development cycle might be, people were able to come in and say, hey, I saw you just released a drawing, or you just released a digital twin of that product. I have some questions about how you want this manufactured, or how you're expecting us to how to create this or manufacture it. So right there at that point, rather than waiting a couple of weeks to find that out, they had that discussion right there real time based on the model, and they were able to make those changes very quickly. So that reduction in churn and that reduction in the cost of rework is a huge win for model-based definition. And then finally, similar to the previous use case one, but this one, we connected various upstream and downstream systems. So not quite as extensive or quite as end-to-end as the use case one, but in this one, we connected basically product development with manufacturing and with the field. So the field services were able to essentially use the 3D renderings of these drawings to be able to go out and service products, build products, help customers, iterate on products, customize products, so they can go out and actually build the next product order using like 3D blocks and say, this is what we want to buy. And then that's what they were able to send back to the production facility. So what I wanted to do here was show a digital cord that is, a piece of the overall digital thread. But, how do the pieces connect in DCM? So what I've done here is listed out kind of the journey I'll take you on. So in a moment here, I'll jump over to back to the website that Emily was showing. But just to kind of set the stage and kind of map this out. So we'll start with the connected customer. So product as a service and connected field services. So customer feedback, field service feedback, maybe issue management, maybe people saying, hey, this is cool, but it'd be nice if it did this or did that. But that comes back real time to the basically the product development team. So that is being fed back to the platform architecture and the systems engineering team. That's being fed back to the digital development team. So the mechanical, the electrical, all the engineers that are doing that actual development work now are seeing these requirements real time and these things from the field real time. Because we're now digital, we can feed all that new product development work to smart operations, and we can do our total operation synchronization. So we can find out very quickly, whether we have in-house, do we have a product that can, or a machine that can accommodate a 4-foot long product, and our latest product is 5 feet long. So we don't have the capability in-house to be able to manufacture this. We know that up front. We know that right away. We can now go out to intelligent supply, and we can go collaborate with our suppliers to find out which one can make that product for us at the best cost. As that comes back, so maybe there's cost constraints or maybe there's capacity constraints in the supply chain, product development again finds out. They go back through and do another collaborative effort. Maybe they do a redesign where that 5-foot piece of material now becomes like 2 pieces that are assembled together, and that actually helps with ease of manufacturing and ease of assembly. And then again, it goes back to the connected customer, right? So as that product goes through the cycle, as the customer sees it, they come back and they provide feedback, and it starts over again. So what I'll do now is I'll walk through that cord, and then we'll come back and I'll show, or I'll basically explain the impact of what we saw when we deployed MBD at this industrial manufacturer. So here we are back at the DCM website. As I said, I'd like to take you kind of through what we call digital cord. So if you think of the overall digital thread, the digital cord are shorter, kind of more pointed connections between the L2s. So if I click on product development, we have various connections to our L2s. There's actually over 1,500 connections between the L2s within this model. So I can see here, just for example, the product architecture has connections across dynamic fulfillment, smart operations, and intelligent supply. So as I mentioned before, I'd like to start up here with connected field services. This again is going to drive that digital product development. So as we start this digital cord, we have some feedback from the field. We have field services coming back and saying that there's some issue with the product, or maybe it's not fulfilling customer demands, or maybe there's an issue with longevity or whatever it might be. That's coming back real time. That signal is coming back to product development. Once we're back into product development, that signal is consumed by the platform architecture team and the digital development teams, both of which have basically connections into, again, customer experience. So we're looking at the customized experience, and also into operations. So as digital development makes those changes and in response to that signal from the field, they're now able, again, to work with the total operations team or total operations synchronization team to determine, hey, this is what we're proposing, for our next product iteration or next product generation. Total operations is able to basically look out into the supply chain, look out into their dynamic fulfillment operations, and have quick early visibility into what's possible or where there might be hurdles or challenges. as I mentioned, in our digital core, our operations team was very quickly able to figure out that they didn't have the capacity in-house to be able to manufacture this new product. So we jumped out the supply chain to supplier collaboration. Again, the suppliers are now working across all these different areas real time to basically consolidate suppliers and find the best supplier, whether it's capacity, capabilities, cost, whatever it might be to satisfy that demand. So the supplier comes back and essentially says, I have the capacity or I don't have the capacity, or you might want to redesign this product because it'd actually be cheaper to make it an assembly rather than one giant piece. So that again comes back to digital product development collaboration, and we start the cycle over. So we now have that supplier on one side, we have feedback from the customers and products out in the field on the other side, and both of these are coming together to drive that cyclic loop of product development. So coming back here to case study number 2, right? So what does this mean? What is the impact? We talked about what we did, how this now impacts and has a thread throughout the from development to operations to suppliers to customers, and then back to product development. So what I want to highlight here and what I kind of want to leave everyone with was this was a relatively simple deployment to do. Their CAD tools and their and some of the connectivity we had to enable wasn't overly complex or complicated. A lot of these tools already have the capabilities to do model-based definition, to be able to create work instructions, to do a lot of the things that enable model-based definition. But basically what we did here is we connected all the pieces, and we were able to essentially have real material impacts across supply chain, manufacturing, design engineering, manufacturing engineering, and quality. The biggest impact was within design engineering. We were able to free up 5% of the team's capacity, just because they were no longer spending time having to redo 2D drawings, having to spend time going down to the manufacturing floor and asking somebody, how would you manufacture this, or that, or vice versa, the manufacturing floor asking them, how should I manufacture this? The work instructions, the dynamic work instructions that were driven by the 3D rendering now become kind of just a indirect benefit, or you create the CAD model and you get the dynamic work instructions. They also were able to work with their supply chain, so going into supply portal and the supply chain groups being able to have access to those 3D models. Again, we saw a big increase of 1.5% on cost of goods sold and cost of goods that they had to bring in house. And then one of the biggest things is manufacturing engineering and quality, right? So the increase in quality was across all their products. So as you're producing hundreds, thousands, millions of these widgets, having that quality increase becomes huge. And then manufacturing engineering is able to really pivot on streamlining operations, looking to make things more efficient rather than having to go through kind of the day-to-day grind of having to recreate work instructions, recreate tooling sheets, recreate all those things. So again, pretty significant impact both on time, money, and just overhead, right, for this client. And I think when we left, they were rolling these out to their North America sites with the plans to essentially roll this out to EMEA and APAC. And again, bringing together the faster collaboration and being able to kind of leverage model-based definition capabilities across their entire organization. So yeah, thank you for letting me present these 2 use cases or 2 case studies. If you have any questions, please reach out, and I'll hand it back over to Jesse and Helly to wrap up our webinar.
Jason, Emily, and Jesse, thank you so much. Really great content and interesting case studies. We have time for a couple questions. The first question is, corporate leaders who are watching this webinar might be wondering where to start on their digital product development transformation journey. Could you elaborate how to approach these transformations?
Certainly, Helly, great question. It is always on everybody's mind whenever we have this discussion. So how do I get started? And there are a few things that you have to make sure are in play to be successful. A transformation, a change for a sake of change never works. So what you really need to get down to is having a clarity of what am I trying to achieve? What is the mission and what is the outcome that I'm trying to look for? And in some cases, that vision and that mission can be very broad, as we showed in the first case study, which was across a much broader scope of the organization. And in the second case study, where it was a very focused effort in solving a problem, but both of them had one thing in common, that the mission and the outcome was clear. Everybody was aligned to let's get to this one piece, solve it, and then how do we go after? So at Deloitte, we often use this sequence: think big, start small, scale fast. So if you have the vision to go a model-based enterprise, great. So think big, do unconstrained. Now let's figure out where we can show that value add and proof of value upfront. How do we start small? And while we are doing this thinking big, it has to come from the entire organization. You should not focus on just one small piece of the organization, say R&D or manufacturing or procurement. In these cases, think broad, because the value for the customer, the cash register rings when all these things come together. And once you have actually shown that value in that smart start small piece, Heli, scaling it fast, now rather than being a push activity that you're forcing upon people, this now becomes a pull from the organization because they see the results and they all want it. So get your vision, a cross-functional buy-in, everybody aligned, let's do a pilot, let's show value, and let's take it from there.
Right, thank you. The second question is, this transformation will impact supply chain talent of the future. How digitizing product development transform current roles?
Change is the only constant, and this change will drive out some of the profiles, some personas, and will create some brand new ones that will be needed to take care of things. A simplest example, we have a team of folks making the drawings. Now they need to make models. It's a upskill. They're already working in the digital environment of doing those drawings and models. How do we now make it outside? Our operators on the manufacturing side, I'm taking the second use case example here again. They were used to getting 2D drawings and translating them into the CNC code. They get an upskill in terms of how they bring in that same model and process it within their structure. So a level of impact in that persona change is limited. There are some pieces of the organization, some parts of the organization which were doing a lot of repetitive work, which were simply tasked to, hey, can you pick up data from the ERP system and enter into my different downstream system? Can you pick up information from engineering and just type it into something? Non-value add work, chances are those jobs, those personas will go away as more and more integration happens. So a combination of upskilling, training folks in the new ways of doing, getting augmentation, AR, VR, in helping them do their job better will continue to expand. And the repetitive work and the low value add work will continue to go down. Jason, Emily, anything else you guys would want to add?
Yeah, I did have one point, Jesse, and again, this is based on our experience and findings as we deploy model-based definition. We were pleasantly surprised to find that, the new workforce, right? These younger people are coming in. They're actually expecting to be able to work in a digital environment. They have their phones, they have their laptops. They come into a manufacturing facility and they think it's old-fashioned, it's archaic, right? Why are we still on paper when I can go on my tablet or on my cell phone and I can see all kinds of things in digital, like real time? So to Jesse's earlier point, as this becomes a pull, people were saying, I want to be able to see this model in 3D. Like, I'm expecting to see this model. The fact that I took a piece of paper, they were, it wasn't nearly as hard to kind of sell this to the next generation of manufacturing engineers and manufacturing, assembly people and the actual, people cutting the chips and metal as we thought it would be. So it was definitely a demand pull based on, our current, how fast everything's moved outside of manufacturing. Manufacturing now needs to catch up and come into the same level of technology that people have in their hand, every day.
And just to add one more element, Heli, as you said, how will it impact people? There will be many new roles created. There are new personas, as we have outlined on the website, if you see, which do not exist today. For example, I am a digital twin engineer. What does that mean? I have ethnographic experts on my team. What does that was supposed to be something totally different. Where does that come into the product development teams now? So the collaboration, understanding of the new roles, new customer needs will continue to drive what a product development team will look like. So a combination of all those things is in front of us.
Great. Unfortunately, that's all the time that we have today. I want to thank you again for sharing your insight with our webinar attendees. This concludes today's webinar. Thanks for participating. All contents and materials included in this ASCM online event are the property of ASCM and are protected by the United States and international copyright laws. All rights are reserved.